So today we can just start with the introduction to BGP. Okay. Yes. So BGP is a protocol. Okay. BGP is a protocol that comes in the category of exterior gateway protocol. Okay. Let me share my screen. So first is open. Open is a packet type that actually initiates what to say. That's a kind of a packet that actually set up or establish the BGP adjacency or BGP neighborship. So it's a open, the packet name is open, but what its function is, it is going to set up and establish a BGP agency with a neighbor, right? Whichever neighbor peer we are going to configure in the BGP configuration. So it is going to establish a session. Okay, that is open packet. Okay, so here actually an open message is sent. Okay, open message is sent to the BGP peering router, whichever router is we have configured as peer. We used to mention that router IP, okay, at the configuration. So whenever we have configured a peer and when we start configuring the BGP session, so the first packet is a kind of an hello packet, like how we have seen in OSPF. So it's a kind of an hello packet, establish the connection between the peers. So both the sides, both the routers are going to negotiate the session. Okay. Whatever is configured as peer on the neighbor router is going to be the same as the source router, A, B router, right? So both the sides, it's going to negotiate when an open message is sent by both the routers. So what this open message contains? It is going to contain the BGP version, the autonomous system number, okay, from the origin router, the hold on timer, okay, and there are other optional parameters as well to establish it. So those are optional. So, but mainly the BGP version, the autonomous system of the originating router, the hold on timer, and the BGP identifier. So these are going to be in the open message. Okay, so that is open packet. So in open packet, we have seen about hold on timer, right? So this hold on timer is again an attribute. It is in seconds. Okay. So for each BGP neighbor, it's going to send an hold on timer. Okay. So it will wait until for that timer to get reset to the initial value. So if the hold on timer reaches to 0, then the BGP session is down. Okay, so before that hold on timer, we need to get a message from the neighbor, okay, acknowledging the open message or acknowledging the connection, right? So that hold on timer is also sent in the open message or open packet, so that it is telling that router will hold this message only for so much time, so this many seconds. After that, it is going to drop this session or this neighbor will be removed if we are not going to receive an appropriate update from the router. Okay, so this hold on timer is also known as a heartbeat mechanism for BGP neighborship. So this is main. So if main, which classifies describes the BGP neighbors to ensure that the neighbor is healthy and live. After the hold on timer, if there is no neighbor is not responding, then the BGP session itself is broken. That's all. There is no connection between the neighbor. Right? So the hold on value must be at least like some 3 seconds. For every 3 seconds, or like it is going to send the open packet, and it will keep that message on to 180 seconds. Okay. After 180 seconds only, it's going to declare that the neighbor is down. Okay. And we have seen that in open message, BGP identifier is also going to be sent. BGP identifier is nothing but the router ID, like how we have seen in OSPF. So it is a router ID, a 32-bit unique number that is going to identify the BGP router. Okay, and this is actually okay. So after the open message is sent, there is an update message which is going to be sent between the BGP neighbors. So I am keep telling it's OSPF, so it is BGP neighbors. Okay. So this update message is actually going to advertise the feasible routes. Okay. Or it is going to update the message that includes the we call it a term called network layer reliability information, or it's a prefix networks. Prefix here we call it as networks associated with the BGP when it's advertising. So basically an update message is just a keep alive message to reduce an unnecessary traffic. It's going to be a keep alive message, or it's going to contain all the message, all the routes, okay, all the feasible routes it's going to advertise. That is there in the update packet. So update message actually advertises any feasible route, okay, and it includes the NLRI. So network layer reliability information. So that is the prefix. That is nothing but the prefix that is associated with the BGP. Okay. BGP peers. And it's going to so this update is also acts as a keep alive message. Keep alive message to reduce the okay. So this is update message, update packet type. What are the packet types we have seen? Notification. Notification and keep alive. Okay. Next packet type is notification. Notification actually indicates if there is an error condition in the BGP. Okay. So notification is sent when there is an error detected in the BGP session. So it is act as a detection of any error in BGP session. Okay. Such as if the neighbor capability or stability is keep on changing, or the hold on timer is expired, okay, or the BGP session itself got resetted due to some link issue. So these causes the connections to be close. So at that time, it is going to send a notification packet, okay, to the neighbors saying, okay, there's an error detected. No, I'm not able to reach this BGP peer router. So at that time, this notification message is sent. Right. Next is keep alive. Keep alive packet. So keep alive packet, this actually ensures the BGP neighbors are still live. By the word itself, it says keep alive. So it is keep on ensuring that the BGP neighbors are still live, or still the sessions are active. Okay. So if a BGP router does not like what to say, does not rely on the TCP connection. So TCP connection, I'll tell you, it's a three-way handshake signal, right? So if it is not getting a TCP connection established, okay, or the keep alive message are exchanged in every hold on timer, and if we are not receiving it within 60 seconds, acknowledgement within 60 seconds, there is no keep alive message sent between the BGP routers. After 60 seconds, there is no keep alive messages. So the session is dropped or session is broken. Okay, so these are the 4 BGP packets. Open packet to establish the BGP adjacency or to establish the BGP neighborship. Update packet is actually contains the advertisements, updates, or if there is any BGP router fails or network fails, then it's going to withdraw that routes from the routing table. So it's gonna, so these informations are contained in the update packet. Notification is where it's is sent only when there is a detection of any error in the BGP session. Okay. And keep alive is to just to ensure the BGP neighbors are still live in the network. So there's a timer of 60 seconds. So until then, it is going to keep the BGP session live, the BGP neighbors live in the network. And after 60 seconds, if still there is no response, then the session is going to be dropped. Okay. So these are the 4 BGP packets. Next. So next is what we are going to see is BGP neighbor states. Okay. So BGP forms a TCP connection or TCP session, okay, with the neighbors, with the neighbor router. So in BGP, the neighbors, we are going to call them as peers, peer, okay. So this session is going to establish between the peers, the peer ID or peer, we have a configuration. So we are going to mention the neighbors as peer. So BGP uses a mechanism where it contains all the BGP peers and their operational status. Okay, the BGP states like before it forms or after it forms neighborship. Okay, this BGP, what is going to maintain a table of all the BGP peers and its operation state. So there's a command show IBGP. Okay, neighbors. So at neighbors, if you hit that command, you will get to know about all the BGP neighbors. Which are the routers it has found neighbors. It is not only to the directly connected neighbors. Okay, it's not like a directly connected neighbor only shown in the output. It will show all the routers where this router establish a connection. Okay, one second. Okay, so so BGP is going to establish a TCP session with its neighbor, and all the BGP peers will be shown in a BGP neighbor output with its operational status. Whether the BGP is down or whether the BGP is connected or does it have any issues, or if it is not connected, then it will like be removing it from the neighbor table. Okay. So here the BGP session has the following states, okay? When it is trying to establish the BGP session, there are 4 states. The first state is idle. So at this state, there is no neighbors formed, okay? Okay, in this ideal state, this means that there is no neighborship formed. Okay, this ideal state, okay, this ideal stage is the first stage in the BGP neighborship before forming a BGP neighborship. So BGP detects this as a start event or trying to initiate a TCP connection to the BGP peer. And this router is also going to listen for any new connection is going to establish from the neighbor peer as well. So router A is going to send or initiate a TCP connection. At the same time, it is also going to ready to listen to the new connection that is going to initiate from the peer. Okay. So this is the first state. So if there is an error in the BGP session or BGP routing, any router which is already functioning in the, or it is already functional in the BGP process, if there is an error caused due to link failure, power issue, or anything, the BGP will go back to this ideal state. Okay. So when we see something in BGP ideal state, that means the connection is down for that particular neighbor. Okay. So it's going to wait for again 60 seconds, and the timer is going to be decremental from 60 to 0. After 0, then it is declared as the connection is ideal. So if the BGP connection is ideal, that means the BGP is down. Okay, you will not be able to send any traffic to the neighbor router, or there is no connection. Network is down of the remote peer. Okay, that is ideal state. So what we can define ideal. Okay, this is the first stage. It initiates the TCP connection. Next is connect. Okay, so in this connect state, so actually the BGP initiates the TCP 3-way handshake, like sync, acknowledge, message. A 3-way handshake is going to establish between the peers. Okay. So here it is going to do the neighbor is going to initiate a request, okay, to form neighborship. And the neighbor router is also going to send a response to this connect message saying that router is active, right? And after that, again, the router is going to acknowledge acknowledge the neighbor's response, and a three-way connection, three-way TCP handshake is completed. And after the completion of the three-way handshake, the BGP session is actually going to be established between two routers. Okay. If there is no input received in the connect state, right? A three-way connection, a three-way 3CP connection, if there is no input received, then the state is again going to change to idle only. Idle state, the previous state. So this means the connection is down. The neighbor is not reachable, right? So here BGP initiates the TCP. Three-way TCP connection, right? And the TCP source protocol number is 179 is used. Okay, this will be also asked in the exam or in the interview. Okay, what is the TCP source port number for BGP? It is 179. Okay, after the connect, it is active state. Okay. So in the active stage, again, the BGP starts after the three-way handshake. It's going to establish the establish of the next message. It's going to establish the next open message. So again, so this is actually a state where after the three-way handshake is done, the connection is established and it is ready to send the next message in the next state. So that is the active state. So this means BGP starts a same only. Okay, it's going to initiate the three-way handshake, and here active state, it's actually it actually starts the three-way TCP handshake, and the connection is established. Connection between the two neighbors is established, right? Next type of state is open sent. Open sent is a state where a message has been sent from the originating router and is awaiting an open message from the other router. Okay, so a message, what that message contains is what we see now. So it actually is sending a message to the message has been sent from the originating router and it's waiting for the message from the other router, neighbor router. Sending message to the neighbor router and also waiting for the message. Okay, so this open sent state actually is going to send certain information, certain fields to the neighbor router. Okay, that is the BGP version. Okay, so it is going to send its own BGP version, and it has to be matched with the neighbor router as well. So BGP version, source IP address, AS number, BGP identifier. That is nothing but the router ID. Okay, BGP identifier, we call it as router ID. Okay, and other security parameters. Like password, any password is set, or TTL, timer. Okay. Okay, these are the informations is going to be sent in the open sent state. So BGP version should match with the neighbor router. Source IP address should match. AS number should match. BGP identifier, the router unique ID. It is unique, so it is not going to be in the same as the neighbor, but it's a unique information. And security, other security parameters like password or TTL timers, whatever is set, it has to be matched with the neighbor. Okay. So these are being verified or matched in the state, open sent state. Okay. And here, during the state, if there is any error seen, okay, while initiating the hold on timer or TTL, or in order to keep alive messages alive, and if there's not matching, or the keep alive is still not live, then again the BGP will go back to the ideal state itself. Ideal state. If something is not matching, then it will go to the ideal state. Okay. Next is open confirm. Open confirm is a state where BGP waits for the keep alive or a notification message from the neighbor. So it is just waiting for a receipt actually of the neighbor's keep alive message. Okay. And the state, once it receives an acknowledgement or a message or a notification or some like you say, some acknowledgement message from the neighbor, okay, then it will move to the next stage. So like if the BGP version is matched or source IP, AS number, everything is matched, keep alive message, notification, it receives an acknowledgement, everything is good, then this open confirm state actually moves to the next state, right? So open sent, these messages are sent or being verified. These messages are being verified, and that timer or the time taken for this verification between the two routers in open confirm state, it is just verifying. All these informations are matched. Okay. And so that is open confirm state. Okay, so BGP waits for a keep alive or notification message. from the neighbor. Okay. Again, if the hold on timer is expired, so at that time when it is trying to verify match this condition with the neighbor, and it is going to cross the hold on timer, then the event of checking this information will be stopped. Okay. And the state will be moved to the ideal state. If something is not matched or something, it is taking time to verify the information, like it is verifying and that keep alive timer, say 60 seconds is beyond that, then it confirms that there is no connection can be established with the neighbor, and it will go to the ideal state back. Okay. That is open confirm state. If everything goes well and all are matches within the keep alive timer, then then we call the last state as established state. Established is in the established state, the actual BGP session is established. Okay, that is the neighbors exchanging the routes using the update message. So BGP, neighbors, exchanges routes, using update message. So update we have seen here, right? Update packet type. So it is updating its information in the update packet type. Update, keep alive, and notification. All are started actually. All the packets are being exchanged between the neighbors. Okay, so this is OSPF neighbor states. And this is BGP neighbor states. This is BGP packet types. Okay. Okay, so this is just a simple topic only, but still this is important. Like how we have seen in OSPF, different neighbor states, right? Down, attempt, init, two-way, start, exchange, loading full. Similar to that, this is OSPF neighbor states, ideal, connect, active, open sent, open confirm, and established. Okay, like OSPF allow packet types. This is BGP packet types. Okay. So with this, you're clear with for today? It's just theory only, but yeah, there are a lot more
The
theory.
point is, whenever it is completed theory, it's very difficult. I'm unable to remember all these things.
Yeah, you will not be able to remember. This is the first time, right? You see, even if you want to appear for an interview, you have to memorize it. These are some theory
But
concepts.
I don't think they'll ask this in interview. Either they'll ask what is BJP and they'll ask how to configure it. Because if you know how to configure it, and all these things are like, okay, if you have some idea, basic
No.
idea, I think.
For any interview, or not for all interview, they are going to ask you how to configure.
Like, okay.
How to configure out what commands you put in the router. Nobody is going to ask you. Rarely,
Mm-hmm.
one or two interviews only, they'll ask for the commands. what command you will put. But mostly they'll go with this concept only. Okay, what is ideal state? What will happen to a BGP neighbor in ideal state? What are the different states of BGP? Like how we've seen in OSPF, what are the different 7 types of
I mean, like, I'm applying for junior network engineer roles and this network engineer roles. I don't think they'll go in this depth.
in-depth, yeah,
Maybe.
in-depth of BGP, nobody goes. So nobody is going to ask you, that's what I'm telling you, nobody is going to ask you how to configure BGP. What you will do in order to do the configuration. Nobody is going to ask because that is not going to be in the junior level. Any junior is not going to touch BGP routing configuration or is allowed to do configuration in the router. Right?
Okay,
Instead,
what they'll do then?
they 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 will just see the work is different. Junior network administrator's role is completely very basic thing only. Like you will log into the switch, check or configure something on the VLAN perspective, okay? Or
Mhm.
you will install a new switch, okay? Or if you will be in the like in as a service desk analyst, like will be like having a ticketing queue where you will get the issues or request in the ticket format. Okay, ticket in the sense as a request. We call the issue or incident and ticketing queue. So you will see some user will be reporting, okay, my desktop is not working. So actually, his desktop is not working. The PC is not working. Its LAN cable is not working. So those kind of issues and all will be you will be assigned with a queue where you will get to receive all these incidents in the form of ticket
Okay.
will be assigned and you will have to take care of these things. Some user
Okay.
might say, no, the network printer, I'm not able to take printer from my machine. In organization and all, there will be a network printer that is shared among everybody in the office. So anybody can sit anywhere and take a print. Just click on print. There's one printer will be used by everyone. So this person alone is not able to take a print. So there is network connectivity to be checked, or some drivers that needs to be installed in his laptop should be checked. So like that, issues will come like that. Okay. So
Okay.
nobody is going to come directly and say routing is not working or switch you need to configure STP. That is not the main thing. Okay, as a junior level, the basic networking, the level 1 issues will come first. Okay.
Okay.
Level 2 task is completely different.
But actually, hello.
Yeah, yeah.
But whatever jobs that I am applying in the job description, all these points are actually not there. They are expecting me to, implement VLAN segmentation and HTTP integration so that,
No, no, no,
and
no. Job description will be like that only. See, the job description will be like that only. Only then they will know that you know to configure a VLAN or you know to configure a switch. Okay. Or you know if if a PC is connected. Okay, if a PC is connected in the network, how to trace which switch the PC is connected. For that, you should know what is VLAN, what is MAC address table, how to trace or how to identify uh, the neighbor from the switch. So all these concepts comes under switching. Okay.
okay.
So no, I'm telling the concept, whatever you're going to study, prepare in CCNE, CCNP, is not directly you're going to apply and start to work, but you will start to work from the level 1 perspective. But whatever maybe the company you're applying, are they recruiting for level 1 or level 2? Okay,
Yeah, I'm looking at associate level in the network engineering, and uh, like
yeah,
I'm going through the job descriptions and I'm preparing based on that. Like
yeah,
if they ask some basic stuff, I don't know. Like have to see. Like I didn't prepare on them.
yeah. So that's what see, interview will be in a different perspective, and the work what you will be doing or will be assigned by the company will be different only. Okay.
Okay.
So to my knowledge,
Yeah, if I'm able to work on the exactly on the job description, then I will be able to do all these things because it's like a much higher level than the basic stuff, right? If I'm able to do, if I'm good at the higher concepts,
yeah,
then I, yeah,
definitely. That's what for any L1, L2 engineer role, which even now in my organization, I used to take interviews. So I will check on these concepts only. So if he is good in STP or in VLAN or troubleshooting a VLAN issue, okay, or
okay.
issue, thing, does he know how an OSPF works, how a EAGRP works?
Hmm.
I'll not ask him the syntax or the commands, but I will ask him how it works. Okay, right. OSPF has so many processes or neighbor states in order to form. Right. So how it works is what we will be asking. So
How it works in the sense like after configuring it itself, we can may understand, right? Like we can configure the router with OSPF and we can check the neighbors whether it is established or not.
that's what you have to explain. After
Uh,
how you will check the neighbor? How the neighbor
yeah,
should.
like show IP router OSPF.
Yeah, right. And that output, what you will check? Which parameter you will check, and you will know that there's a neighbor for.
Hmm.
So those,
Usually we can use CDP neighbors or and you can check the host name, password, domain name, and all the information of that is present in the router, like
yeah,
all the interface information.
that is what they will expect actually. Instead of,
Sorry.
no, that is what they will expect in the interview. Instead of me directly telling the command.
Directly I won't tell the command. Like first I'll try to explain in this way, and if time permits, I'll try to explain the commands too, so that they'll have some idea that okay, he's good at configuring it, and he also knows the commands too.
Okay, okay.
Please share it all this.
Yeah, sure, sure.